Warm welcome to Ushendra's engineering tutorials. Yet another important video from the playlist Control Systems, a very underrated topic. We can say that a very underrated topic, block diagram reduction. It's a block diagram reduction and signal flow graph go parallelly. So once you are okay with the reduction rules, you can obtain the transfer function of any sort of given block diagram. It may be that much tedious, but once you're thorough with the the expert says, once we are thorough with the reduction rules, we can obtain the transfer function of any sort of given block diagram. So some important, not some important, all the, let me reveal all the reduction rules and try to do reduce a block diagram. Okay, so from the very fundamental, what sort of reduction rules from here, you come across blocks like this one. Okay, let's suppose we have a block G1 and G2 like this. G2, make sure nothing is in between this block and this block. You may have anything on either side. You may have this one, we have a name for this one, and another, this, you may have this component or this component on either side, but make sure nothing is in between these two, and under that condition these two blocks are known to be in cascade, in series, in cascade. So this, from this point to this point, from this point to, from here, this point to this point, we can make it into a single block. That's a reduction G1, and these two are multiplied with each other, G1 and G2. Okay, so we have this element over this side and this element over this side as it is, one of the basic reduction rule. Okay, so this one, these two are in cascade and can be made into one block. Another reduction, let's suppose we have some block like this one and give a name G. Okay, G, a signal A is coming from this side over here. So what signal do we get at the output? It's a AG. So this signal is multiplied with this one, and this has got a name, transmittance, A into G. Okay, it gets multiplied with A into G. I mean, this signal gets multiplied in the transmittance and output will be, it's a AG. Okay guys, what will be the signal from this point if we take a wire connection like this one? From this one, it's an extension, right? Again, it's a AG, no change in that one. Take n number of wires from this point, the same signal will be obtained on the end of that wire connection, isn't it? So we have a name for this one, guys. This one, this point, node, they say something, but technically this is known as a takeoff point. Takeoff point, they call it a takeoff point. While obtaining the transfer function, making use of reduction rules, we may be in need of shifting this takeoff point to this side of the block with respect to this one. Okay, I repeat, during the reduction process, we may be in need of transferring this takeoff point which is ahead of the block to the to behind the block, this side. From, it may be like this one over this point, but we may be in need of shifting this takeoff point to this side. So what reduction rules comes into the picture? What the expert says is, the expert suggests that you do whatever you want. Take a box like this one, inside you do whatever reduction you want to do inside the block, but finally the input should be A, and that output from this one should be AG. Even from this point should be, it's a AG. Do whatever you want. That's the conditions apply. Okay, so here what, it's a AG, it's a G, and it's a AG. Output from this point also should be AG, but I am in need of shifting this to this side, over this side. Okay, the takeoff point should be brought to this side, which helps me to reduce the block diagram. Okay, so under that condition, but it's still, it's just from, if it is shifted to this side, it's simply A, isn't it? Right? So what I have to do is that this modification should be done inside the box only. Okay, like this one. inside the box, and it's only A from here. So what should I do? Like I need to introduce another block, because with respect to this block, so I need to introduce a block with the same duplicate of this one, and then that gives me A into G. Okay, the previous one we have shifted this one, but the same thing, A input A, from this point it's AG, and even from this point it's a AG. This is one of the important reduction rules. Guys, here something has to be stressed on some important point. You may have number of components around this one, but keep focusing only this part, only this part. You may have something else after this. After this point, you may have something, another block. Okay, don't focus on that one. While going for this change, focus only on this and this. Okay, with respect to, is this with respect to this block or another block, like that. Okay, so that is very important. And what to do with the reverse process? Like I have a block G over here, and I have a signal A, and what is that? What is that signal we obtain over here? It's a multiplied with the transmittance G, so it's a AG over here. Okay, so what if we have a takeoff point? What if we have a takeoff point over here? So what will be the signal over here? It's simply A is coming over here. Okay, and during the reduction process, we may be in need of shifting this takeoff point, which is behind the block, to ahead of the block. We may be in need of shifting the takeoff point on this side, right? Anything can be done inside the block. Any reduction can be done inside the block, but the signal from this point should be AG, and from this point should be A. So if at all this is shifted to this side, this takeoff point is shifted to this side during the reduction process. Now it's AG, isn't it? Now it's AG. No, what do we want to have? It's simply A. So what we do is, because the shifting is done with respect to this one, what we do is we introduce a block. Okay, giving the name 1 by G, the reciprocal of this one, the value of reciprocal of this one. Now up to this point it's a AG, isn't it? AG. After this, AG is multiplied with 1 by G. Okay, so from here it's a AG again. Now this AG is multiplied with, this AG is multiplied with 1 by G, and that G which got included gets cancelled, and finally from this very point it's a only. We have shifted the takeoff point from this point to that point, this side to that side, but still we made this modification, and we made sure that the input and output from this point and this point is same even after reduction is obtained. Okay guys, so remember, even this is important. Okay, and we have another component to be shifted. Okay, so there is another reduction, important reduction, guys. The same G again, the same G. Okay, and A again, A, right? So guys, now this time we have another component. Remember this one, this is a takeoff point. Okay, this node, they call it, more technically in control systems point of view, they call it a takeoff point. Now we have another element to be shifted, that which will be in need of shifting while reduction process. It's known as a summing point, where 2 signals, 3 signals, 4 signals gets added, simply added, nothing to get confused. And we have another signal like this one. Okay, let's keep the name B. Okay, so it may be added or subtracted, plus, and for the time being it's a positive and a positive. So what we have is, what signal do we have over here at this point? Here at this point it's A plus B, isn't it? A plus B. So what will be the output over here, this point? It's if we don't have this one, it's A multiplied with G, because we have the summing point, and the signal over here is A plus G. After emerging from this block, the signal will be A plus B into G. isn't it? So that is AG plus BG. Okay, so during the reduction process, once again, during the reduction process, we may be in need of shifting this summing point which is behind the block. We may be in need of shifting the summing point to this side. Okay, any reduction may be done, any modification may be done, but we have to stick to that conditions apply. The signal A, we shouldn't disturb the signal A, we shouldn't disturb this one, and we shouldn't disturb the output also. AG plus BG should be as it is. Any modification can be done according to the convenience, but this and this shouldn't be disturbed. Okay, so over here, focus over here. So what is that? Here we have a G, transmittance G, and what is that modification? This summing point should be taken ahead of the block. So we have a signal A as it is outside the block. Modifications done inside this red area. Any modifications can be done, but we have to stick to that. Output should be as it is, no change in that one. Okay, so that summing point is taken ahead of the block. Okay, so if this is the one, so what signal do we have over here? It's a AG over this point. Over this point it's a AG, and it's a positive and a positive. It's a positive and it's a positive. Okay, and what do we have over here? It's a B, isn't it? So finally, what signal do we get over here? It's a AG added with simply B. AG, it's AG up to this point, it's AG, and the signal is added simply B. Okay, but what do we want to have? This one, BG, isn't it? So AG we have plus BG is missing over here. So what should be done is we have to introduce a block with the same transmittance G. Then what signal do we have over here? It's a BG, B multiplied with G, and finally we'll be having AG is over from this side and BG from this side, so it's a plus BG from this side. So this is can you see that it's a AG plus BG over here? We have done the modification, but still the input is same. We didn't disturb the input, we didn't disturb the output, but still modification is done. So can you make the difference between this and this? Here, summing point and take-off point moved ahead of the block, but this introduced with, this is multiplied with the transmittance G, and this is divided with the transmittance, the inverse process. Okay, so this is the one. So guys, we have to make use of all these. Okay, and ahead of the block and behind the block, yeah, one is done. So here another reduction rule. What if we have the same transmittance G over here? It's a G. Okay, we have a signal A. So what will be the, and what if we have a summing point? Previously it was here, right? Now we assume that the summing point is over here, and what modification to be done if we have to shift the summing point to behind the block? Okay, let's see. We have a summing point over here with the positive and positive. Guys, it may be negative also, the same process, right? And focus that only on you may have n number of blocks around this one, but focus only on, close everything and just focus on the summing point and just the block. That modification with respect to which block we are doing, focus only on that one. And what if we have a B over here? B, what signal will be the output from here? It's a AG, and these two, B comes over here from this side and AG. So what output do we have here? AG plus B, isn't it? So, and once again, we may be in need of shifting this summing point to this side. We may be in need of reduction to reduce the blocks. Okay, so during that process, what do? We can do modification, anything inside this one, the square, but we shouldn't disturb the input, we shouldn't disturb the output. Output should be A plus JB. We can do any modifications, conditions apply. Yeah, so if that is the case, the summing point moving ahead of the block. So G over here, okay, and we have a signal A plus, and B, the summing point is brought to this side. It's a B over here. So what signal flows over here? It is A plus B, right? Up to this point it's A plus B, and after this one, this A plus B is multiplied with G. A plus B is multiplied with this G, so AG plus BG. But what do we want to have? It's AG and only B, right? So what should be done? Introduce a block over here. Introduce a block over here with what? 1 by G. Okay. So now up to this point it's A from this side, and B multiply up to this point. It's a B by G. B into 1 by G. So it's a B by G over this with this modification. Okay, with this modification it's a B by G, and the entire signal is multiplied with G, isn't it? So A into G, it's AG. B by G, in the sense B by G, B by G, B by G, B by G is multiplied with G, so this gets cancelled, and finally what the output is? AG plus B, isn't it? Yeah, we got the same output. We have done the modification, but we made sure that there isn't any change in the input, and the output isn't disturbed, right? Remember, output should not be disturbed. It should be as it is. Any modifications can be done, any modification is allowed, conditions apply, output should be as it is. This is one of these two, I mean, yeah, summing point and takeoff point. Yes, this is just the basic, right? Remember, it's known as a takeoff point, and this one just a summing point. Summing point, that's it. Signals are added. Okay, so yet another important game changer, we can say that a game changer, reduction rule, eliminating the feedback loop, they call it. Eliminating the feedback loop. Yeah, believe me, while you practice, you can come across this state. You will experience this one. Everything, all the given block diagram, during the reduction process, finally what we have is, we arrive to that block in such a way that it's in a feedback loop. It matches this one finally. So two blocks like this one, a block with the transmittance G, and another block with a transmittance H, right? And so guys, a takeoff point from here, a feedback, and a summing point from this side given to this one, a signal. Make sure that how the direction is, the signal flow direction. Okay, let the input be R. Guys, we have G of S, H of S in S domain, right? For the time being, I'm not writing that as R, and signal is flowing in this direction with the positive. Signal is flowing in this direction and in this direction. Okay, this is the output. C, right? Technically, that's the representation for the output, the standard representation, and this is the connection. Okay, so guys, remember, it's a negative feedback. Two types of feedbacks, isn't it? Positive feedback and a negative feedback. So this is added and this is subtracted. The output which is fed back is subtracted from the input. Okay, so this is the one. So where do we have to start from? We can start from any point, the discussion, but still, what is over here? C, right? If you have a C over here and a wire is connected over here, what signal flows over it? C again. No change in that, isn't it? So nothing to worry. Yeah, and one thing, any modification can be done over here. Any modification. Let's see if how it gets reduced to. A very important one. More focus should be on this one, right? Finally, why? Because all the blocks will be finally reduced to this this arrangement only. We'll have to make sure that the given big block diagram, it may be with a 10-15 number of blocks, but we have to make sure that all the blocks finally we come to this point, a feedback point. Okay, so what do we have over here? It's a C. That signal which is up to this point, it's C only. It's C, Okay, it's C, and after this it gets multiplied with the H, so it's a CH. Over here it's a CH. Okay, and this CH to the summing point. So what do we have over here? After this summing point, what signal do we have? R from this side, R, and CH from this side, minus, it gets subtracted, CH, R minus CH. Okay, so this one, after this, what will be the signal after the block? It's R minus CH multiplied with the transmittance G, which is equal to C only. Yeah, which is equal to this. So how to write down that one? C, which is equal to this one, R into G minus CH into G. Okay, we have C on this side, and pulling this CHG to LHS, what do we have? Plus CHG, which is equal to GRG, right? Taking out C as common, to 1 plus G, more precisely GH, which is equal to R into G. So guys, we are in search of a valid ratio, ratio, that is output by input. Our output is C and input is R, which is the transfer function. So what is that? C by R, which is equal to G by 1 plus GH. So guys, we have this 1 plus GH when we have a negative over here. If it's positive, that will be negative. Remember that one. So what this says, what should be concluded from this exercise? So the conclusion is, if it's a closed loop, guys, check, focus on the takeoff point. We have to focus on signal is entering and another signal is leaving from this point. Okay, here it's going away, it's going, and after this point, it's after this node, a signal is entering and a signal is leaving. Make sure this one. Okay, so what is that conclusion? From this point to this point here, from this point to this point, entire we can remove this one summing point, we can remove this one, and we can represent from this point to this point. No more summing point, no more takeoff point. From we can say that R, and this entire arrangement can be represented in one block, giving this one, this transmittance G by 1 plus GH with a single block, and R is as it is, and C stays as it is. One of the deadliest important reduction rule in block diagram reduction rules. A game changer, right? Believe me, whatever block will be made sure that it comes to this arrangement. Okay, this one, we can remove this one, and entire from this. We have to make sure nothing is in between this one, nothing is in between. Yeah, even this is. Many students asked me while in the live class, what the hell, why don't we reduce? Yeah, we should make sure that nothing is in between this summing point and G. No takeoff point or anything. No, we shouldn't have anything like this one. Nothing should be between G and G and this takeoff point. Nothing should be in between this and this. We have to make sure that nothing should be in between this block and the summing point. Nothing should be in between the summing point and G. We have to make sure that, right? Yet another very much similar but confusing block diagram arrangement. It will be like this one. We will have a G block with the transmittance G and a summing point over here, and a summing point added, and another signal coming from that side gets added. Okay, so what it is, another block, give the name H, and like this one. So now you may come across even this point also, guys. You may have another arrangement like this one, and takeoff point, guys, you may have this one signal. Let's say the signal is flowing in this direction, this one, like this. like this, like this, like this. Can you see the difference? Can you see the difference? This takeoff point, okay, it's a summing point, it's a summing point, something else after that, but can you see the difference? It's entering and it's leaving. It's not this one, it's entering, but after this point, like yeah, see this, it's taking this diversion and getting back to this. It's a closed loop. Yeah, signal is flowing, it may be this, it's going, coming back to this point. Now this is known as a closed loop. This isn't a closed loop. Check, it's flowing in this direction. Is it coming back? No, arrow is pointing towards that side. Here it's a this, here you need to focus much more, and here it's going in this direction, of course, this direction, but that isn't coming back to this point. Bit difference, okay, so that you have to focus. And what modification to be done over here, guys? These two signals are added, simply added, right? So how from this point to this point inside the block, we can make single block. It's a single block, it's a G plus H, simply you have to. So it's up to you, you have to make your common sense, you have to use your common sense while if you come across this one and this one, there is a bit difference. It's a closed loop, it signal is starting from this point and coming back again to this point. It's a closed loop, whereas this one, it's starting from here and even this is going away towards forward, right? So under this condition, this signal, whatever coming from this side gets added, whatever is coming from this side gets added, and so from this point, eliminating the takeoff point and summing point, and we can represent this arrangement in a single block, and the transmittance will be this, the transmittance of the single block will be G plus H. Okay, so even this one, beginners do get confused with these two. Yeah, we have seen in the live classes, we have experienced that in the live classes, beginners generally get confused with these two, right? One is closed loop, one is that isn't a closed loop. Signal is flowing ahead, nothing, it's not coming back. Here it's coming back, but it may be in reverse direction, upside down, but you have to check. It's up to your common sense. Take some few seconds, watch that carefully and make sure signal, the flow of direction of the signal. Okay, and these are the important rules. Yeah, another another modification to be explained over here, that is guys, generally in block diagrams you come across this one. It may be one signal, it's a summing point, isn't it? I've told you, summing point, one signal, it may be from this side, coming from this side, and another signal, it may be from this side with the positive, another signal from somewhere from far away, it may be coming, and you may come across this negative. Okay, it's tedious, you cannot go ahead. This could be split into two. How that is? Positive from this side, positive from this side, and another positive from this side. Extend that, extend it, add it, another just add it, okay, and another negative. This could be splitting the summing point, they call it splitting the summing point. And one more point, that can't this be interchanged? Can't this be interchanged? Of course we can interchange that one. We can write like this also. How it is? It's a positive and it's a negative, and extend it, it's added positive, and it's positive again. Yeah, this is one of the important rules. We can interchange, we can exchange, we can change the position of the summing point, and we have to make sure nothing is in between this one. Okay, if you come across this one, this could be split to this type, or else in the block diagram during the process you come across, you may come across that situation where summing points are next to each other. We'll have to make sure that nothing lies in between these two, nothing comes in between these two, and we can interchange the position according to our convenience. That is allowed in the block diagram reduction rules. Yeah, of course. Okay, now this one, if we'll have to make sure nothing is in between these two summing points, and we can interchange the position according to our convenience. Another point is, guys, takeoff points here, we may have a takeoff point over here from this side, and we may have a takeoff point from this side or this side or that side. The positions can be 1, 2, 3. We can change the positions. We can go for 3 can be brought over here, 1 can be, and 2 we can interchange. Only condition applies, nothing is in between this takeoff point and this takeoff point, which we are trying to interchange the position. All right, that's the only point to be remembered. Nothing should come in between these two, and nothing should be in between these takeoff points. Yeah guys, there is yet another important but very tedious, very seldomly asked. Yeah, it's a positive, another positive over here. We will have a takeoff point over here. We may be in need of shifting this takeoff point to this side. Do we have a rule like this one? Yeah, some authors discussed, but very tedious, very rarely asked. You come across that one, very rarely asked. So off the record, if at all you come across this reduction, and if you are not able to go ahead, suggestion is convert that to signal flow graph and then obtain the transfer function. Usually this happens in the competitive exam. They won't specify, they ask you the transfer function. So you follow whatever procedure you want, then give the transfer function. Yeah, if you come across this, if at all you have this one, if at all you have to interchange this one, it's really tedious, time consuming, it will waste your time. So yeah, it's left to you, it's left to you. So yeah, what we do generally is we convert that to signal flow graph, which is the easiest process, and then we give the transfer function. Signal flow graph is after block diagram reduction, isn't it? Not signal flow graph doesn't come first and then the block. No, first we discuss about the block diagram reduction, and then we go for there is a drawback. This is the big drawback in block diagram reduction. If at all we have to the reduction, if at all we come across this interchange in the reduction process, it's a tedious one, almost impossible. Yeah, it is possible, but very tedious, very time consuming. We may go wrong. So because that's tedious and it's a time consuming, to overcome this drawback, signal flow graph is introduced. It's an easy conversion. If you remember the Mason's gain formula, you can give the transfer function at a snap. Yeah, practice that also, suggestion. Okay, so guys, this is the reduction rules. Let me solve a simple problem making use of all these reduction rules. Okay, yeah, this is enough. These are the reduction rules to be remembered while we go for the block diagram reduction. This is enough. Okay, so let's consider an important for the beginner, a block diagram reduction for a block diagram to be reduced for a beginner. Let it be G1 over here, and let's have a G2, and somewhere it's a G3. Okay, yeah, what do we have over here? He made it a bit tedious. A signal from this side flowing in this direction. We have I saw a summing point over here. Simply it's a positive and a positive. Another signal over here. Okay, we have to focus on the flow of the signal also, the direction of flow of signal also. And over this side, a block is introduced from over here. A block is introduced giving the name transmittance H. Okay, and added. It's simply added over here. It's a positive and it's a positive added over here. Okay, and he made it a bit tedious. A signal there exists a takeoff point over here, and yeah, we have there exists a takeoff point over here and a block over here. Give a name. It's H again. It comes in this direction, and where it is, even this gets added over here, but with a negative. Now we have to split this summing point, and there is another summing point over here, signal in this direction, and there is an overlap. It's not touching each other, okay? And it's a unity feedback. It's a negative again. It's input R added over here. Yeah, is this the block? Of course. Yeah, this is the block to be reduced. For a beginner, make a note, please. Let us exercise on this one, making use of the question is, do we have to make use of all the rules while obtaining the transfer function using a block diagram reduction, all the 6 to 7 rules? No, but these two are repeated again and again. These comes into the picture, guys. G, takeoff point this side, taking that side, we need to introduce 1 by G, and summing point to that side, bringing that summing point to this side, just inverse with the takeoff point and summing point. That is repeatedly used. Why? Because expert says try to shift from the inner loop, try to shift all the summing points to the LHS, and whatever takeoff points existing in the block diagram to the RHS. So majority times we come across this is repeated again and again. So why that? To reduce that to a single feedback loop. Okay, so all the summing points to LHS and all the takeoff point. This is a takeoff point, this is a takeoff point, it's a takeoff point. It's already in the LHS, that isn't a big deal. So we have to do something with this one and this one. So to that side, takeoff point to that side, summing point to this side, expert says. Okay, during that process, guys. However, here a small simplification over here. This one, this takeoff point, and this could be done at a time. Okay, we cannot do this, will be tedious if we shift to this side. We don't have that, we have that property, but that will be tedious. So shifting this takeoff point to this side will be tedious. So what according to the block diagram reduction techniques, the easier way will be shifting this to ahead of the block. Similar to this one, we have a takeoff point over here. Shifting this takeoff point to ahead of the block, we need to introduce G 1 by G, isn't it? So in this case, I am doing the simplification here itself. I cannot draw it again, the complete block diagram. So I am doing the simplification here itself. It's very much similar to this part only. Forget about those components around this one. No, close away this one, close away this one. Don't bother about the flow of that arrow, that signal. Close away this one, close away this one. Only focus on only this one. Focus on only this one, this takeoff point and this G2. So according to that reduction rule. So what it is, we need to, if we have to shift this takeoff point to that side. So guys, this it's a negative. Okay, it's a coming back and it's negative. It's a negative feedback. So what to be done? Takeoff point which was here should be shifted to this side, isn't it? So we need to introduce a block with the transmittance according to this one. It should be with respect to this, so it should be 1 by G2, isn't it? So this one, this over this point and this point, right? Yeah, we are done with that one. And this is given in the question itself to screw you, to put you in trouble, to test you if how far are you ready with the block diagram reduction. So guys, this one could be split into two parts. Here this line, this connection could be simplified even much more like this. Erase it away, please try to go slowly. We have one line signal flowing in this direction, and we have another wire like this. Okay, and here after this node, the signal is flowing ahead. Even this signal is flowing ahead. Yeah, it's like this one. We had G flowing in this direction. We had a summing point, and this one we had a summing point, and another signal also G. Let this be H, like this one, very much, isn't it? Just now we have seen that in this direction. After this one, it's flowing in this direction. Even this is, it's not coming back, to that point. No, it's going ahead. It's a feed forward, not feed backward. It's a feed forward. So completely, how can this be eliminated? It's a G plus H, isn't it? one block, eliminating this one and this one, we can reduce that to single block. This transmittance plus this transmittance with the block. Okay, similar to, if that is the case, there is nothing over here, so that can be taken as a 1. We have a unity feed forward, so completely, in the sense, we have a block with a 1, if nothing is there, that isn't open, isn't it? So guys, completely this part, it's a feed forward, this part is a feed forward and can be represented with a single block with the summing. It's added, in the sense, guys, you can erase this one, we can completely eliminate this one from this point to this point, even the summing point and the takeoff point, and can be substituted with a single block. And with the transmittance, it's a this plus this, and there is nothing, in the sense it's unity feed forward, so it's a 2. Okay, and here itself we can have another simplification. Here it's a continuation, signal is moving forward, and nothing is in between, nothing is in between this block and this block, right? Nothing is in between this block and this block, so are in cascade and can be made it into single block, and it's a 2G3. Okay, 2G3, it's simply 2 single block with the transmittance, twice of G3, so even more precisely, twice of G3. Okay guys, don't get confused with the G1s and G2s. Why? Because malfunctioning will give an error, like we shouldn't have a square term. We generally don't get a square term while block diagram reduction. That's another reason. You can understand if you solve a series of problems. Okay, so here what simplification can be done? Here, can you see this? It's moving ahead, okay, and this one, starting from this point G2 and coming back with the H, transmittance H, coming back to this point, it's going and returning back. It's a feedback with a positive feedback. It's from the beginning, I'm telling you, it's a positive feedback. Okay, even that can be done, right? Even that can be done, or else this could be shifted to that side, this could be combined, right? Anything, we have a number of ways, right? Do we have only unique procedure? No, transfer function is unique, but procedure wise you can simplify this one, or else after shifting this to that we can cascade this one, and then the simplification can be done. Okay, so okay, let me leave this away and let me shift this takeoff point to that side. Okay, this takeoff point to that side, even this takeoff point to that side. So if at all we have to this takeoff point. Now forget about everything, all the components, all the blocks, forget about all the blocks, all this connection. This takeoff point is to be shifted ahead of 2G3. This takeoff point has to be shifted ahead of G. So what did we do? We didn't touch, only we have made a modification over here inside. The output is same. So for that case, we introduce a block with the transmittance 1 by G. So here, if I have to shift this ahead of that one, what should I do? What should we do? We have to introduce a block with the transmittance, because ahead, right? So this rule comes into the picture. It's a 1 by 2G3 should be introduced, and the takeoff point can be placed over here. Okay, so this is also existing as it is. What it is, it's a H over here. I didn't do any modification. Okay, I need this place. So guys, in the same way, even this takeoff point could be shifted to that side. Right, once again, what to be done? If this takeoff point has to be taken ahead of twice of G3, again what we have to do is we need to introduce a block with the transmittance 1 by 2G3. okay, and this connection from this, the takeoff point will be over here. Okay, that's a reduction. and see, nothing is in between this block and this block, nothing is in between this block and this block, and nothing is in between this block and this block. Why? Because we just shifted the takeoff point which was in between, making use of the reduction rule. Okay, so this can be combined into a single block, and the transmittance will be, guys, don't get confused with that one. Okay, if I'm not wrong, if I remember, if I'm not wrong, it's 2 G2 and G3 over here. Okay, and this will be, nothing is in between this block and this block, so even this could be, it's a, guys, I'll be usually forget it, so it's a, no, it's, this can be replaced with a single block, okay, with a single block, 1 by 2 times G2 G3. Okay, so this is the one, right, if I'm not wrong. And this one, even nothing is in between, so we can erase this one and this, and we can introduce one, so it's a cascade, so it's simply multiplied, isn't it? So guys, now have a watch here. This can be, as we interchange the summing points, even though takeoff points can be interchanged. And there is yet another important modification over here. We have 3 signals entering into the summing point, so that could be split into, that should be split into 2 summing points. Okay, signal is coming from this side and entering here, it's adding. Signal is coming from output again and it's adding. Another signal is coming from this side and it's adding. So it will be tedious, that couldn't be taken forward without splitting, so we have to split that. Right here, we have this line. Okay, I'm not erasing this away. We have this line, it's an overlap over here, this one. Okay, so how to reduce that? Let me show you. It's a summing point, the bigger one, it's a summing point. Okay, a signal from this side, it's been added, even from this side, even from this one, it's added. Okay, so done, we are done with that one. Okay, so continuation, we have another summing point. This signal gets added, which is from this side, and this signal here, this signal with an overlap with this one, that gets subtracted. So that's how we split the summing point. Okay, so here we have this added, we have this subtracted, we have this added and added, right? So guys, this is the procedure, and let me take this down, okay, as it is. What is that? This block as it is, this block, let me take it down as it is. It's a 1 by rewriting 2 G2 and G3, isn't it? So guys, this connection, this one, this connection, and we don't have this anymore, I mean, that connection is reconnected over here for convenience. So can you see something here? Can you see something? Some signal is going forward, it's going forward, and something, it's coming backward, okay, it's a feedback loop. Now this one will be G, this one will be H, whatever transmittance, now transmittance G, and this one H. So how to eliminate from this point to this point, making what rule is that? So it should be, if you remember, it's negative. Okay, from the beginning we stick to that, it's negative, it's coming back with it's been subtracted over here, it's a negative feedback. And so what we have, G by 1 plus GH, negative feedback, and so G by 1 plus GH, isn't it? Now this entire transmittance will be plugged in over G, again G, and this is H. So the simplification will be twice of G2 G3 by 1 plus twice of G2 G3 and H. So this is the single block. We can remove this summing point, the takeoff point, this block, and can be represented with a single block. Okay, so that is this one. So I'm erasing this one away, guys, so make use of this one. So remember this one, we don't need this anymore. Okay, we don't need this anymore.
it's here. Yeah, we don't need this anymore, right? So we can replace from here. We had the second summing point, isn't it? So that could be removed away, and with a single block it's 2 times of g2 g3 by 1 plus 2 times of g2 g3 into h. This is the single block. Okay, so this was a simplification. Yeah, this was the simplification, right? And it's moving, it's a main loop and it's going ahead, it's a feed forward, it's going ahead, and after this point it's coming back. See, it's coming back. That forms another closed loop with a positive feedback. Here it's a positive feedback. This from this point to from this point to this point, it's a feedback, it's a positive feedback. If that is the case, how that is? Once again making use of this one, g by 1 minus gh in the case of positive feedback. It's a positive feedback, and so g, now this one, it's a main one, it's the main g, and this is the transmittance h over, like this case. So g by 1 minus g into h. So how that simplifies, how that should be simplified? It's a g in the sense entire twice of g2 g3, right? Twice of g2 g3. We don't need this anymore. Why? Because we are at the last stage. Only the feedback, we need to understand only the feedback path. g2 upon 1 plus 2 times g2 g3 into h. This is for g, entire g, isn't it? So 1 minus twice of g2 g3 by 1 plus twice of g2 g3 into h, into h part, this one, into h by twice of g3 into twice of g3, right? Something gets cancelled over here, guys. I guess this one, 2, yeah, only 2 g3 and 2 g3. We have g2, right? That doesn't get cancelled. g2 still exists. Twice of g3 gets cancelled, right? So in that case, yeah, and even this could be like, we need to simplify this one. We cannot leave it as it is. Here it's in the numerator, what do we have? Twice of g2 g3 by 1 plus twice of g2 g3 into h, and what do we have in the denominator? Simplifying this one, what we have is 1 plus twice of g2 g3 into h, and we don't have anything. See, watch carefully, that one in the denominator, cross multiplying 1 plus 2 times of g2 g3 into h, and this one minus of g2 into h, okay. So guys, something gets cancelled over here, this one, this denominator, and same, they are alike, g2 g3 h, g2 1 plus g2 g3 h, this gets cancelled, and we'll be left with only this one, okay. This gets cancelled, so for me not to get confused, I'm erasing it away. Yeah, that's, we can eliminating this too. It's a feedback with a positive feedback. We can remove this, and we can with this single block, with this we can represent the entire these two blocks with the summing point and the takeoff point with this single block, making use of the eliminating the feedback loop reduction process. Okay, so in the sense, this could be taken away. We can erase this away. We don't need this anymore. Okay, even the takeoff point, we can take it away. Here, this one, entire this thing, it can be removed and can be replaced with a single block with the transmittance twice of g2 g3 upon 1 plus twice of g2 g3 into h minus g2 into h. Okay, now this one, and guys, see, nothing is in between these two, right? Nothing is in between these two, so these are in cascade, can be multiplied, so we don't have this anymore. That could be included in this block, and it's a g1. Now see, we have finally arrived to that feedback with a negative. It's a negative feedback. Okay, can you see this R? And I forgot to mention the arrow mark over here. It's going. After this, it's coming back. Why? Because we have stick to this one. Okay, now we have it's coming back and with a negative feedback. So this entire transmittance will be taken as G and H. It's a negative feedback, so this comes into the picture, right? G by 1 plus GH. Right, now this is entirely G by, it's here, twice of G2, G1, G2, G3 by 1 plus twice of G2, G3 into H minus G2 into H. Okay, this 1 plus, why? Because it's a negative feedback, so obviously it's positive again, twice of G1, G2, G3 upon 1 plus twice of G2, G3, H minus G2 into H multiplied with, guys, multiplied with 1 by it is G upon 1 plus G, this gets repeated again, into H, this part is H, so 1 by twice of G2, G3. Guys, make a note, something gets cancelled over here, 2 gets cancelled because these are being multiplied, isn't it? These two are getting multiplied, and G2 also gets cancelled, G2, yeah, G3 also gets cancelled, and what is left over? Yeah, we need a small simplification. It's only, let me erase this away. I'm a bit confused looking at all that number of G's. It's a 2, it's G2, G3 gets cancelled. Yeah, we are left with that one, and into 1, what to do with that 1 again. So guys, this is the leftover, whatever is left over. Simplifying that one, what do we have here? So guys, this gets repeated again, right? So it's a, what is that? 2 times of G1, G2, G3 upon 1 plus 2 times of G2, G3 into H minus, still we have G2 into H in the denominator, and simplifying this one, 1 plus 2 times of G2, G3, H minus G2 into H. Okay, so we have to cross multiply that one, so 1 plus 2 times of G2, G3 into H minus G2 H from the first term plus G1, isn't it? So guys, something is common over here, something gets cancelled. Yeah, this one, this entire, this denominator and this denominator are equal. Yeah, if I'm not wrong. So this is the reduction. Take it, and I'm erasing it away. Okay, no, finally what we are left is, what will be left with is, it's a 2 times of G1, G2, G3 upon this one, 1 plus G1 minus G2 into H plus 2 times of G2, G3 into H, right? 1, we got that 1 plus G1 plus minus G2 into H, yeah, G2 into H plus twice of G2, G3 into H. Guys, now this one, this is the reduction, in the sense removing this, it's a feedback loop. Okay, it's a feedback loop, so this could be eliminated completely with that C over that side, output over that side, input over this side. Yeah, with a single block. What is the transmittance of this block? This one, twice of G1, G2, G3, this 1 plus G1 minus G2 into H plus 2 times of G2, G3 into H. So guys, this, right? So I cannot rewrite that again. Now the transfer function. Now the transfer function which we are in search of is C by R is equal to, this will be the transfer function of the given block diagram, making use of obtaining the transfer function of the given block diagram, making use of block diagram reduction technique. So remember, all the summing points to LHS and takeoff points to RHS will be the best procedure, easier procedure. Right? Make use of your comments. Start from the inner loop. Start from the inner loop and then start solve. So this is all for today's video. Today's video, not to this video. I need your support, guys. Please support me with your valuable subscription. It's a humble request. Thanks for watching.